Good morning. Thank you for joining us today. I'm Lisa Rayburn, and I'll be the moderator for the first part of the morning. I want to go over just some basic housekeeping. We've got our Caneberry educational session going on this morning, and we want to make sure that you have access to the things that you need. So in today's day and age, we all want to know what is that password for our Wi-Fi. So if you're trying to get on the Wi-Fi, you can use the password on the screen. AgNet Media's Specialty Crop Industry is our Wi-Fi sponsor for this year, so if you see them, give them a thank you. We want to make sure that you don't forget to download the conference app. You can scan the QR code on the screen. Just use the camera on your phone. It should read it and take you directly to the app. If that doesn't work for you, you can open your App Store and search for Southeast Regional in either your App Store or Google Play. Don't forget that if you need your continuing education credits, you can scan your badge at the reader by the door. So just make sure you scan to check in for each of your educational sessions. That's how we're going to make sure that you were in the room to get the credits for whichever session you attended. Don't forget to check out our trade show. We've got a lot of good booths there in the trade show. It's open today and tomorrow. Today it's 9 until 6, and tomorrow it's 9 until 2:30 p.m. Make sure you check out all the vendors, and a lot of our sponsors are in that room as well. So this conference wouldn't be possible without the support of our cooperators. So we have a grant and a cooperative agreement with the USDA's Department of Agricultural Marketing Service. And we really appreciate the Georgia Department of Agriculture for its partnership and administration of this. And don't forget to check out the silent auction. It is located outside the trade show entrance. All of the bidding will take place on a text-to-bid platform. So if you want to participate in that silent auction, you're going to scan the QR code on this slide. And of course, just use the camera on your phone. Or if you have the app already downloaded to your phone, you can click on the silent auction within the conference app. Bidding for the auction will close at 2 p.m. and the winners will be able to pay online and pick up their items after that closing time. This year, we are recording all education sessions as long as the speaker gives permission. The recorded sessions will be made available to all of our registered attendees after the conference. And we need to hear from you. We need you to take the time to tell us how we're doing. Please take the time to fill out your surveys, which are listed here on the ends of the table, kind of in the salmon pink color paper. You can either do a paper form. If you prefer, you can do the survey within the app, or we'll also send out a survey by email after the conference, and you can do your survey there. But this feedback helps us both do better for next year and make sure that the topics that we're providing are the topics that you need to do your business better. What are the things that you need to know to grow your business? All right, so with that, I would like to introduce our first speaker this morning. Our first speaker is going to be meeting with us by video today. It's Amanda Davis. Amanda is a senior faculty research assistant in berry crops with Oregon State University. And Amanda very graciously videotaped her presentation and then got up really, really early to be available to answer questions at the end. So we're going to start with the video, and then we will, if we have time, take questions at the end, and Lisa will be online to answer them for us. I'm sorry, Amanda will be online to answer them for us.
Good morning, everyone. Thank you for being here, and I really appreciate the opportunity to present today. I am going to be talking about some research that I've been working on with my supervisor, Dr. Scott Lucas, and this is work that was started by Dr. Bernadine Strick and in cooperation with Dr. David Bryla, who I know is speaking here this morning as well. So I'll just give a little industry overview for the Pacific Northwest at the beginning, and then we'll dive into our research that we're doing on primocane management and plant spacing, and working really on ways to reduce labor cost while maintaining quality production that we're known for in the Pacific Northwest. The Oregon blackberry industry, as of about 2017, which is the last year that the statistics were taken, we had about 6,300 acres with an average yield of 3.2 tons per acre, which comes out to about 40 million pounds. And about 90% of that fruit is going for the processed market. So this is getting typically machine picked, but not always. And then it's getting frozen in individual quick frozen process and going into the frozen market. Most of the machine harvested fruit are trailing floricane fruiting cultivars, which is going into that processed market. A little bit of that does go for fresh. And then we also have the semi-erect and erect varieties, as well as primocane fruiting varieties that are primarily being handpicked and sold into the fresh market. Some typical practices here in the Northwest, like the last picture showed, either grass alleyways, or in these pictures we have the bare soil alleyways. Fertilization is typically done with granular applications, fertigation, or a combination. Some folks are doing granular in the first part of the spring when there's still a lot of rainfall, and then switching to fertigation once the rains stop coming down and those granular applications won't be effective anymore. For primocane suppression, it really depends on the grower and also the variety. It's not something that everybody's doing, but there's been some research in the past that shows for some varieties it's not so helpful and can even be detrimental, and for other varieties it is actually helpful. Caning out and training is typically done either in August or in the January, February, sometime in winter. So that's what we're showing in these pictures down below, where we're taking out all the floricanes, the primocanes are left there on the ground, and then we have a team of people that comes through and wraps them up onto the trellis wire. And with these trailing varieties, they can have canes that are, 20, 30 feet long sometimes, depending on the variety. So this is a pretty arduous, time-consuming process for the people that are doing it, and it's expensive for the growers as well to pay those people. Now, in the last 5 or 10 years, more and more of our growers are using this new over old technique instead of that former way of doing it, where we're caning out all of the dead floricanes and training those primocanes up on the wire. This is kind of what this new over old looks like. So the floricanes don't get caned out at all. They just die and they remain kind of in this mass of plant on the canopy, on the trellis. And then the primocanes will grow through that canopy and kind of up and over. And then as the canes grow, they just get either tucked through or thrown up and over onto that canopy. So this is a huge labor savings. This is why everybody's, a lot of folks are doing it. But there's questions about how that impacts our yield, and do we get any differences in fruit quality or fruit size, or is there issues with disease and, botrytis or mildew on the fruit or on the canes themselves? So these are questions, we're not 100% sure about. This is another picture of what that looks like, and you can see the primocanes growing through this canopy sort of these dead floricanes. And then these are the fruiting laterals growing in the springtime. These are some of the top varieties that we're growing. Of course, Marion, a lot of folks might be familiar with that. It's sort of what the Northwest is known for. But more, within the last 15 years or so, Black Diamond was released as a cultivar from the USDA breeding program in cooperation with Oregon State. This one is really popular, and it's got a more sort of compact growth habit, so we get a lot of fruit in a small amount of space and really in a small amount of cane material. And then Columbia Star was released in 2014. So this now accounts for about 26% of the acreage in Oregon. And it's a lot more dense of a canopy. We get a lot more cane growth, and the fruit are nice and firm, and they hold up really nicely to machine harvest while having good fruit quality and flavor, compared to Marion, which is really delicious, but it's quite soft, and it's very thorny, and it doesn't hold up as well to machine harvest. So like I mentioned, Columbia Star was released in 2014, again by this cooperative breeding program in Corvallis, Oregon. It's a thornless variety, machine harvestable, and it's a trailing variety. So these are some pictures from the cultivar release. It's a really nice shape fruit and very consistent. And it has better fruit quality than some of the existing varieties, along with having good yields. Like I mentioned, it has a vigorous growth habit. So it's pretty different from the Marion and the Black Diamond and some of the other more standard commercial cultivars. So, you know, this is getting planted on really wide acreage, and it's still a relatively young cultivar in our industry. So there's questions about what the best ways are to grow it while still getting good yield and keeping our labor costs down. So that's where our research project comes in. In 2019, we got funding to start this study looking at primocane management and plant spacing to really reduce labor costs and maintain quality fruit production and, of course, the yield. This is work that was funded by the Oregon Raspberry and Blackberry Commission, as well as the Northwest Center for Small Fruits Research. And like I mentioned, we're collaborating with Dr. Bryla, who's working on irrigation requirements and plant water use in the same variety of blackberries. The objectives of our study were, again, to look at the impact of plant spacing, primocane management, and our pruning and training methods on plant yield, fruit quality, how the plants are growing, and then labor requirements. So every time we have to come through the field and tuck the canes out of the way or train the canes, we're keeping track of how much time that takes in order to be able to compare these treatments against each other in terms of the expense that it's going to cost to the grower. The field was established in the fall of 2019. It's under half an acre. We had to replant in the spring of 2020 because we had a frost pretty soon after planting, and that knocked some of the plants out. The planting is being drip irrigated and fertigated, and like I mentioned before, we're maintaining bare soil between the rows. And we used a little bit of tillage early on in the study, and at this point, we're just using herbicides for this trial. Our first treatment is looking at plant spacing. So 5 feet plant spacing is sort of typical for this area, depending on the variety. Some folks might go down to 4 foot, but really 4 to 5 feet is pretty standard. So that's what we went with for our standard plant spacing. And then we doubled the density. So the other plants are at 2.5 foot between plants, with 10 feet between the rows to allow for tractor clearance and harvester clearance. So at planting, or soon after planting, that's what that looked like on the left. And then within the first year, you can see on that bottom picture that at 2.5 foot plant spacing, the plant had really filled into a solid canopy on the trellis, whereas with the 5 foot plant spacing, there was some gaps in the canopy after that first year. Our next treatment is training method. So the August training is how we're doing half of the field. Like I mentioned, we cane those fluorocanes out in August after they've died back and train the primocanes up onto the wire. And then that's compared to using the new over old system where we're not caning out the fluorocanes at all. They all remain on the trellis and they just sort of break down and remain there or fall to the ground as they break down. And the new primocanes are trained up and over the canopy. And finally, we're looking at primocane suppression. So primocane suppression is basically coming through with a burn back herbicide. We apply it one time each season when the canes are about 1 foot tall. This is typically in late April or early May. And this is a picture in the first year in the first main growing season where we had fruit. On the left is having no primocane suppression, and on the right is with primocane suppression. And these are on the August train plants, so you can kind of see the individual bases of the plants there. In 2023, this is what this looked like in August train and new over old. So even though we have a pretty wide, dense canopy, and this is just me going through with a backpack sprayer because we're using such low volume for our small acreage, spraying AIM one time really does help clear out that canopy and burn back the primocanes, and they'll start growing back another week or two later. So for the 2023 season, like I mentioned, we did our one primocane suppression on May 5th when the canes were about 1 foot tall. This is our third harvest year, so I'll be talking about some of the yield and quality data from this year, but also what we've seen in the first couple of years of this trial as well. We collected data at caning out on the fruiting lateral length and the number of fruit per lateral, as well as primocane length, and then, like I mentioned, keeping track of the labor requirements. How much does each one of these things, how much time do they each take? Our harvest occurred from June 29th to July 15th, so that was 5 harvests twice a week during that time period, and this was all done by machine. And so looking at our yield, at our 5-foot spacing, we got about 9.5 pounds per plant, compared to 5.1 pounds per plant at 2.5-foot spacing. So this makes sense. Each plant has a little bit more space. You can get more yield per plant. But what was interesting was that in the first 2 harvest seasons, we were getting significantly higher yield per acre at the 2.5-foot plant spacing. Obviously, we have double the number of plants. So even though it's lower yield per plant, that yield per acre came out quite a bit higher. So 2023, like I mentioned, that's our 3rd harvest season, and our yield per acre was not significantly different anymore. So the 2 plant spacings really leveled out at that time, and we got an average yield of 4.3 tons per acre. Now our 2022 yield was much higher. We got 7.5 tons per acre, but I think there's a number of different factors coming into play here. Our 2021 yield was low, and we had stress due to heat dome. We had good weather during bloom and early spring, and there might just be some compensation going on. We had the higher yield the year before, lower yield this year. And we'll talk a little bit about some of the other potential factors that played into that in a bit. Our new over old training had higher yield than our August training. This was kind of new this year also. So new over old yielded 5.2 tons per acre compared to 3.3 tons per acre with August training. So now we have this practice that's saving us time. It's much easier to do, but potentially also getting higher yield out of it. So this is looking like a win-win situation here right now. And there was little effective yield due to primocane suppression. This is a practice that's really, fortunately, if it's a practice that a grower wants to use, it's not having an impact on yield in general in this year or in prior years. We were curious if any of these treatments affected our ripening rate. Now, because we're machine harvesting and the way the treatments are laid out, we do have to harvest them all at the same time. But we still wanted to look at, are we getting fruit off any earlier or later because of these treatments? Because that could impact, potentially be beneficial to a grower if they can get fruit off a little earlier and get it into the processor before some of the other varieties or the main peak of the fruit. And so what it looks like is that we're actually getting a higher percentage of yield harvested from the new over old on the first harvest compared to August training. Now, I have a few different thoughts about this. So one thing is that the new over old has this big canopy, and when you come through with the machine harvester, you're potentially just knocking off more fruit because of this big canopy, and there's lots of canes everywhere, and the fruit's just coming off. And so I was curious, we'll see this on the next slide looking at our bricks. But that's potentially, we're just getting some of that fruit off a little earlier than we did with August training, where maybe there isn't as much canopy there to just knock that fruit off. But it's potentially, it's a 10% difference in the total yield harvested. That could be good for a grower. And so that's something that we want to keep an eye on if that is consistent from year to year. And then throughout the rest of the season, you can see that on the third harvest, that sort of balances out. And then by the end, they're pretty much the same. Okay, I mentioned the bricks. So at 5 feet spacing, our average bricks was 13.7, which is great for this variety, and no difference due to training. But at 2.5 feet plant spacing, our August train had 14 bricks compared to 12.8 with the new over old. So again, we have that dense canopy. Maybe we're knocking fruit off a little bit earlier. But I went back and looked at the cultivar release paper for this variety, and their average was 12.7 bricks. And so we're above kind of what that acceptable standard was when they released the variety. So I think that anybody would be happy. These are definitely edible, ripe fruit at 12.8 bricks. 14 are definitely nice and sweet, but it's not necessarily a make or break situation here. Our primocane suppression, there were some differences in bricks, but they weren't as large and probably not very noticeable and probably not very important to the grower in this situation. For our berry weight, we actually had higher, larger berries, heavier berries with new over old at 7 grams compared to 6.6 for August trained. So that was interesting as well. And there was no effect of plant spacing or primocane suppression on berry weight. When we do our harvest, we pick out the cull, so that's going to be anything that's unmarketable, overripe, underripe, moldy, anything that's you wouldn't want to eat. So our cull in general was lower in 2023 than in past years, which was great. And there was no effect of primocane suppression. Again, this is a trend. We're not seeing much impact at all of this practice. And we had about 5% of the total plant production that was sorted out as cull. At 2.5 feet plant spacing, we're getting a little bit higher cull, 5.5% for new over old than we do with August training, but no difference at 5-foot plant spacing. For ground losses, this is the amount of fruit that just falls on the ground during harvest. It gets knocked off and it falls between the catcher plates of the machine. Then we come through after harvest and pick that up from a section of the plot. We had higher ground losses with August training than with new over old at 5 feet plant spacing. And I suspect that there might be just a little bit more gap in the canopy, that the harvester isn't really closing up around that gap. And there's kind of getting some more holes in that catcher plate system. Whereas when we have that solid canopy of new over old, or we have the higher density plant spacing, there's really nowhere for that fruit to go except onto the catcher plates. And in general, this ranged from 7 to 10% of total fruit produced, which was similar to last year. And I would say is a fairly standard amount for a machine harvest. Looking at our primocane growth, this is counting the number of primocanes per plant and then measuring them at the time that we're training in August. So this is a picture of, one of those August trained plants caned up, and you can see the large amount of primocanes there. And what we're finding pretty consistently is we're getting more primocanes per plant at 5-foot plant spacing compared to 2.5 foot, which again, higher yield per plant. It makes sense. These plants have more space to grow, so they can grow more primocanes. But actually, the primocane length are pretty similar between those two plant spacings. What's interesting is with primocane suppression, when we come through and spray out that first flush of canes, we're ending up getting more primocanes per plant, so 16 compared to 12. But the primocanes are shorter, so that's sort of coming out in the wash. We have shorter primocanes, but more of them with primocane suppression. And without primocane suppression, we get fewer primocanes, but they're longer. They have a little bit more time to grow. So I think that's why we're not seeing a difference in the yield. It's sort of compensating for itself. And with our training method, we're getting more primocanes per plant with August training compared to new over old. Could potentially be that there's more sunlight hitting the base of that plant, potentially impacting the crown and how those canes are emerging. But no significant difference due to in length due to the training method. Now, these are pretty hard to measure in those new over old systems, but we think we're doing a pretty accurate job of it. For our floricanes, our lateral length was similar between treatments. They average about 15 inches from the floricane to where the ends of the fruiting sites are. Now, with berries per lateral, in 2022, we had an average of 5 berries per lateral. But in 2023, we were down to 4.4. So, I think that that's part of what contributed to a lower yield. It doesn't seem like a huge difference, but over the course of a whole acre, that really adds up, having a 0.6 fewer berries per lateral. Again, we're seeing more berries per lateral with new over old compared to August training. So again, 0.6 more on average per lateral. So that's probably contributing to our higher yield with the new over old system compared to August training. And we did see a similar trend in past years, but this is the first year that was a significant statistical difference. So that's really interesting. And so why might that be? Well, here's a picture of the new over old part of the planting in late fall, or in the fall of 2023. So this was a few months ago. And you can see how much these primocanes have grown. So these were all trained up and off the ground. The ground was bare in August when we went through and did the training. But in a few months' time, you can see how much these things have grown and how much sunlight exposure there is. So we know that the flower buds for next year are already, they're forming in that fall period in all those canes. And so I think, we have so much better sunlight infiltration and exposure in these new over old systems compared to the August train, where we've wrapped everything pretty tightly around each other and around the wire. And so those canes are growing as well, but not quite to the same extent that these new over old ones are. So I think that that's contributing to our increase in yield also. On our cane training, these are sort of general trends over the first 3 years. But what we're finding is that the new over old only takes 10 to 15% of the time that August training requires. So that's a huge savings in terms of time and cost to the grower. Now, the first year it was more like 30%, so 70% less time than August training, but that was because there was no established canopy yet. And really, once we have a framework of dead floricanes and growth on that trellis, the primocanes are much more inclined to grow through it, whereas that first year we had to spend some more time placing them and sort of tying them onto the trellis to keep them in place. So new over old, again, a huge time saving over August training and higher yield. For our 2.5 foot plant spacing, you can see that on the left with new over old. That increases our training time by about 35% for August training, but really similar time for new over old. So you can play with your plant spacing a lot with the new over old system without having a lot of increase in labor for training. Whereas 2.5 foot with August training, you can see we have 8 plants in this plot. And it's very time consuming and pretty challenging to cane out the floricanes without cutting the primocanes, and then to separate out these canes and train them up. It's very time consuming and probably not very, it's definitely not desirable for our crew of students and myself, and I know that labor crews probably aren't too excited about it either. Okay, looking at primocane suppression, this did reduce our training time 20 to 50% depending on year, but it's not as important in new over old. Again, you can see these canes in this photo are growing out through the top of the canopy. This is prior to harvest in 2022, whereas when we do primocane suppression, they're really not growing out through that way. And you probably don't need to kind of tuck them out of the way prior to harvest. So our primocane suppression reduced training time throughout the summer. So in June, usually we have to come through, like I mentioned, and get canes out of the way before we come through with the harvester so we don't drive over them and break them all. It only took 11 hours per acre to do that with primocane suppression compared to 28 hours per acre if we did not suppress the primocanes. And then in August, we had 107 hours per acre versus 115. So we're saving some time throughout the season and a comparatively low cost to spray that one time. So based on product and the amount of time it takes to drive through the field, I estimated that at $58 per acre to do the spray. Looking at the economics just based on yield and labor costs for training and primocane suppression. So this isn't including all of the many other costs that go into farming. And so, we're aware of that, but this is just to give you a sense of what these individual treatments are doing for the grower. So in 2023, using the new over old method saved about $4,000 to $6,500 per acre versus August training, and it had higher yield. So because of that lower yield in 2023, the cost of August training at that high density 2.5 foot plant spacing was actually higher than our income potential. And that's not even including any of the other costs that go into it. So that's not looking great. Part of this is just because of, the price to the grower hasn't been great for machine harvest or for fruit, and also increasing costs for labor. But basically, we're looking at the greatest net return with new over old training. It is a little bit higher with 2.5 foot plant spacing because we had slightly higher yield, but like I mentioned, those yields per acre were not actually significantly different. So, you're looking at $7,500 to $8,000 per acre net return, just looking at the price paid to the grower for the fruit and then the training costs. We did get slightly higher returns with primocane suppression despite having similar yields, and that's because of the reduced labor costs that I mentioned. So this is a work in progress. We have one more year of this study to complete in 2024, and then we'll do kind of a more comprehensive cost benefit analysis for those 4 years. And then after that, we have really great potential for doing more research in this field. We have an established planting, and I think it'll be important to look closer into the disease aspect of it, because that's definitely a concern for growers, is managing the disease. We haven't seen a huge issue with this yet at this point, and we haven't had to do additional disease management fungicide sprays because of this new over old treatment, but I think it's something to pay attention to and something that obviously the growers are interested in and concerned about. So we want to keep an eye on that. And then we'll be able to kind of give a final report on this after this final year coming up. So I just wanted to put in a plug. This is our student and employee crew that does this work. Dr. Scott Lucas is the lead of the program, and then myself and Pat are faculty research assistants within the program. And then we hire a bunch of high school and college students to work for us. But, we got some of these ideas from our growers. So this is something that they were doing, and I think it's really important as growers to be communicating with your researchers. And I know that, you know, your researchers here in the Southeast are as receptive to grower input as we try to be in the Northwest. So I would just say, if you've got ideas or concerns, just reach out to your extension and research folks, and I'm sure that they would be happy to work with you and help. So thank you for your attention, and we want to just appreciate our funding sources and in-kind support from industry donors, including for harvesters and plants and fertilizers. And finally, my email is there at the end of on the last slide. And if you have further questions, please feel free to reach out, ask questions, and I will hopefully have a few minutes for questions and answers as well. Thank you.
All right, thank you. Well, good morning, everybody. So today I'm going to continue the conversation that Amanda just presented on this research that we're doing on Columbia Star Blackberry. If I have time, I'll also talk about some research that we've been doing in raspberries. This work was conducted by my previous graduate student, Jess Carroll, who's now an assistant professor at Missouri State University. My technician, Scott Orr, who basically set up the trials that I'll be showing today. Amanda, who you just met. Dr. Bernie Strict, who was a longtime professor and research horticulturist. Unfortunately, she passed away this past year. This work is supported by the Oregon Raspberry and Blackberry Commission, the Northwest Center for Small Fruit Research, and Washington State Department of Ag Specialty Crop Block Grant. So here again is that field site of Columbia Star Trailing Blackberry. As Amanda mentioned, it's a floricane fruiting cultivar, machine harvested for process market, which is primarily the type of blackberries that we grow in the Pacific Northwest. In Oregon are the machine harvest type, and most of that fruit is going to go for processing. So typically we'll start harvesting in early July, depending on the cultivar, and then continue into early August. So this field was established in 2020. And our objective was to develop crop coefficients to estimate irrigation water requirements for blackberries. So first question you might have is, what are crop coefficients and how do we develop them? So what a crop coefficient is, it's a way to take weather conditions and convert it into the water requirements for your crop. So the simple equation here is you have ETC, which is crop evapotranspiration, which simply means crop water use. So the amount of water that's being used not only by transpiration from the crop, but also evaporation from the soil. So that's often combined because it's very difficult to separate those two. And the way we calculate that is we get potential evapotranspiration, which we can get from weather stations, and multiply it by a coefficient for that specific crop, which basically takes into consideration of what the dimensions and how that crop grows and so forth, and how that affects water use. So in the Pacific Northwest, we have a series of agricultural weather stations that collect weather data, and then from that weather data we can get potential evapotranspiration. So you can just go to these sites. It's all online. You can get potential evapotranspiration for a site that's located near your field. Same thing in Georgia. You have these agricultural weather sites located throughout the state. You can access the information online and get information on potential evapotranspiration for your area. So how does this work in terms of getting potential evapotranspiration? Well, what it is these weather stations will measure weather conditions, things like solar radiation, air temperatures, wind speed, plug that into a complicated equation, in this case called the Penman-Monteith equation, to calculate what's called potential evapotranspiration. So what is the potential water use in your area? And that, again, is going to be determined by your weather conditions. So the hotter and drier it is, the more water use there's going to be. Now, this equation was developed for a reference surface, specifically a 4-inch tall field of tall fescue grass. So clearly a blackberry plant is not necessarily going to use the same amount of water as a grass field. So what you need to do then is take that potential evapotranspiration, multiply it by a crop coefficient to get your crop water use or crop evapotranspiration for blackberries. So how do we develop crop coefficients? Well, one of the best ways to do that is to actually measure the water use of your crop. And the way that we're doing this is that we install these soil tanks, in this case 3 feet wide, 5 feet long, 5.25 feet deep, planted it with blackberries, and that tank is then sitting in a chamber on top of load cells where we can actually measure the amount of water use throughout the course of the day. So with that, we can then sort of back calculate to get our crop coefficient. So we get our ETC, or how much water our plant's using, from those lysimeters, divided by the potential evapotranspiration that we get from the weather station to calculate the crop coefficient. So in that way, we can calculate crop coefficients throughout the course of the growing season. So here are the lysimeters that we installed. So on the upper left are the outer tanks that we dug the pits for, put them in the ground. On the right is just another picture of that. On the bottom is the outer and the inner tanks. And then again on the bottom right is us installing one of those outer tanks. Here's with the inner tanks installed. There's Scott Lucas and Jess Carroll in the upper left standing inside the tanks as we installed them. We put soil moisture sensors at various depths. We also had a drainage system so that we knew not only how much water was being lost by transpiration, but how much we were losing through drainage. And then on the bottom right are those load cells that inner tank sits on. So here is an installed lysimeter that Scott is now downloading data. So he's collecting the data, how much the weight is changing over the course of the season. It costs us about $25,000 to install each of these. And the idea when you install a lysimeter is that the plants growing in that lysimeter should be exactly like the plants outside of the lysimeter. Otherwise, if they're smaller or if they're bigger, you're not going to really get a good estimate of your crop water use. So here is just an example of data with the weather conditions on the top 4 panels, and on the bottom is potential evapotranspiration in the white circles and the actual evapotranspiration that we measured with the lysimeters in the green circles. And this was the first year. This was the second year after planting. So this is just an expansion of that evapotranspiration. So again, the white circles are the potential evapotranspiration, the green is the crop evapotranspiration, and then the bars above is the precipitation. And as you can see, evapotranspiration is going to be higher in the middle of summer, of course, because it's warmer and drier. Plants are using more water. And at this point, you can also see that the plants are using less water than a grass field would use. So again, we can then back calculate, we divide ETC, the green dots, by ETO, the white dots, to calculate our crop coefficient. So here are the crop coefficients for the first 3 years after planting. So our first year, our establishment year, second year is our baby crop year, and then third year is the first year of full production. So here in the establishment year, you could see how the evapotranspiration increased as that canopy developed. You could also see that when we tied the primocane wires to the trellis, the primocanes to the trellis wire, there's a slight drop. So basically, we're reducing that canopy, so it's less light interception. So that crop coefficient, or the relative amount of water that those plants are using, declines a little bit. The other thing you see is that this dip that occurred in September that year. We had pretty extensive wildfires that year, and here's a picture I took at 7 o'clock in the morning from my back window of my yard. You can see it was pretty intense how much smoke was in the air. There's not an actual fire there, but this is what the sky looked like as a result of the smoke. Well, that, of course, is going to have an effect on your crop ET. Here's the second year. Now, this particular year, this was the first year of fruit production. So again, you can see when we tuck those primocanes before we harvest the plants, there's a decline. You could also see when we prune and train those primocanes, the crop coefficient declines, but in general, it'll increase over the year. Now, another thing that happened during this year is we had a very bad heat dome event where we actually got to well over 100 degrees. I think we got to 107 degrees in late June, right before harvest. Well, this caused quite a bit of damage to the plants. So when you damage a crop, of course, you're going to reduce water use. So we did have some impacts during that second year. Finally, during the third year, this year we had a great year. Production was great, plants grew great, so we pretty much got what you expected. So what you can see here is, again, the crop coefficient increases over the course of the growing season. So as the canopy develops, get more leaves, it's using relatively more water. So you could also see there's a drop when we tuck the primocanes prior to harvest. You could also, after harvest, there's a slight drop, and then, of course, once we prune and train those primocanes, you reduce that canopy size, and you reduce the water use. So again, water use is going to depend on that canopy development, but it's going to be affected by your practices, things like harvest, things like post-harvest. You can see how that canopy changes relative to what it is with pruning and training. So the total seasonal water use is shown here. So we have the rainfall each year in acre inches, potential evapotranspiration, the evapotranspiration from the blackberry plants, ETC, amount of irrigation we applied, and deep percolation. Of course, ETO varied from year to year, but ETC increased as those plants got larger and reached maturity. Overall, that first year, the plants used about 26% of the amount of water that the potential evapotranspiration was using, so what a grass field was using. The second year is about 34%. I would expect it would have been even higher had we not had that heat dome event in late June. And by the third year, when the plants were mature, the crop grew very well. It was about 72%. We repeated these measurements this last summer, and they were pretty close. We got about 75% of ETO this past year. So we did reach about full production, or at least full canopy, by that third year. So the question is now, one thing that we can do with a lysimeter is determine how much water do we need to irrigate a blackberry plant. So one fun thing that we can do is we can calculate how much water it took in a given year to produce one single blackberry. Take a guess. But basically, it took about 2 liters of water, or half a gallon of water, to produce just one single blackberry. And it took about 12.5 gallons of water to produce enough blackberries to fill a 6-ounce clamshell. Now that seems like a heck of a lot of water, but if you look at other fruit crops, this actually falls pretty close to what you would expect. To produce one apple requires 33 gallons of water. Your hand, yes?
Is this including natural rainfall as well?
Yeah, so this would be just the actual water itself. So regardless of where it's coming from, whether it's from rainfall or whether it's coming from your irrigation, that's how much water it takes to produce the blackberry. So of course, on a drier year, you're going to need more irrigation to do that.
Yeah. Thank you.
Yep. Other things that we're trying to do in this particular study is we're trying to relate what we can collect with drones or UAVs, unmanned aerial vehicles, so that we can actually fly a grower field and develop crop coefficients. Now, the nice thing about crop coefficients is that they're linearly related to canopy cover. So the more canopy cover you get, the higher the crop coefficient. And this has been shown time and time again, crop after crop, that relationship is always linear to a certain point. So what we can do then is we can fly a field with our drones, and we can actually estimate canopy cover based on what we see in those images. And right now what we're doing is we're starting to develop programs using artificial intelligence where we can quickly analyze those images. So for example, here we have a field of Meeker on the left, Wakefield on the right. These are 2 common raspberry cultivars that are grown in the Pacific Northwest, and you can see that the canopy development in Wakefield is quite a bit bigger than that of Meeker. Now, if we take that relationship that I just showed, where you have the relationship between your crop coefficient and canopy cover, and we look at what the canopy cover, the maximum canopy cover was in Meeker, you can see that crop coefficient in that case was about 0.7. We look at the canopy cover in Wakefield, you can see that we're getting closer to 1. So basically what we could do now is we could fly the fields, we got this information, we can see that Wakefield, that cultivar requires about 50% more water than a field of Meeker. So our hope is that eventually we can get this information quickly, we can fly a grower field and estimate crop coefficients and use that information to irrigate or schedule irrigations accordingly. The other thing, as I mentioned, was we measured the changes in soil water content at different depths. So on the bottom is is the daily changes in water content. And basically in blackberries, the first year, we find that the roots go about 2 feet deep, 3 feet wide. The second year, it's about 2.5 feet deep, 4 feet wide. So we could see that's on that bottom, that's our water uptake was primarily occurring from the top 2 feet of the soil throughout the growing season, except when it got really hot, the plants were extracting water down as deep as 4 feet. So we do know that the root system is going that deep. And this is important because if you're going to calculate your irrigation frequency, you need to know your effective rooting depth, or how deep those plants are producing roots. So we now have that information where we can use this in our calculations to determine how frequently to irrigate. So in summary, in this particular study, some key results is that we're developing new crop coefficients. So what we do is we upload these crop coefficients to the weather network site, and then that information then is automatically available to growers. So instead of just having estimates of what that crop coefficient is, we now have actual crop coefficients that can be uploaded into these ag weather sites to give accurate information to growers on their water requirements. The other useful bit of information is that we now have good information on water productivity. In other words, how much water does it take to produce a blackberry? And then we have good information on the rooting depths of blackberry, which is important to know if you're going to schedule irrigations. So, looks like I have time. So, any questions on this particular study? Yes?
Did you guys find, or is it better to full irrigate, like shorter?
That's a great segue, because I got a second part of my presentation that I'm going to talk about that exact question. So thank you. Yes.
As far as so this water is going to be fueling plant growth as
Mhm.
well as berry growth.
Right.
And I know you were trying to generally standardize your plant size so that, the lysimeter information is going to be, replicatable in terms of how much water per berry kind of thing. I guess where I'm going with this is would varietal difference based on plant size, plant density, cane density, those types of things. Do you have any ideas on the differences in that and that kind of thing? I'm just kind of wrapping my head around
Right.
the data and how it works and that kind of thing.
Yeah, sure. I showed you that one graph. I don't know, maybe I noticed you got up, so maybe you missed that particular graph. But there's a strong linear relationship between canopy cover and crop coefficients. So once we develop that actual relationship, the thought is then, regardless of what that canopy size in that grower field is, we can then have an accurate estimate of the crop coefficient. So we're going to start validating that. We won't look at different cultivars, of course, because we'd have to dig up what we have there and start all over again. But what we can do this next year is we can compare what Amanda found with that new over old training versus the standard training where we just create that figure 8 and compare to water use. So we will now have basically one lysimeter that's going to have very different canopy development than the other lysimeter, and we can look at that relationship again and kind of get at that question. Yeah, so that's the idea. Any other? Yes, there's one there.
Did you guys see a difference, if it was really humid out there versus dry? We're a lot more humid than you get.
Sure. Yeah. And that's the key here of using a crop coefficient. So when you estimate your crop ET based on potential evapotranspiration, your crop coefficient. So the crop coefficient doesn't matter where you are. It doesn't matter how dry or how wet you are, unless you're in real extreme environments, because that's just taking into consideration the physiology of that crop itself. It's the ETO that's going to relate to your weather conditions, so whether it's warmer or cooler or drier or whatever, that's going to affect your ETO. So yeah, your ETO is going to be different here in Georgia than it is, say, in our summers in Oregon. So when you do these calculations, you get this information from your agricultural weather stations. It's going to take that into consideration. So you're going to get an estimate of ETO from your weather station, which is affected by your weather conditions, and then multiply it by a crop coefficient for that particular crop. So this crop coefficient, in theory, should be good for any type of caneberry, no matter where they're growing. Yes? Right. Yeah, in blackberries, we really don't do tillage. Even some growers will actually even have grass alleyways between the rows. So we don't really do any tillage during the growing season itself. We might do it in the wintertime, but in the spring, summer, and fall, we don't do anything. And that's pretty normal. Yeah. Okay, I'll move on very quickly to a second study that we've been doing. And this was the feasibility of looking at pulse drip irrigation. In this case, we looked at it in red raspberry. Again, this was done by my graduate student, Jess Carroll, my technician, Scott, Chris Benedict, and Lisa DeVetter, who's be speaking next from Washington State University. So pulse drip irrigation, what is it? Well, basically, rather than applying all that water at once at a given time, say in a 4-hour interval, you split up that application of water into short pulses, say in 30-minute pulses over the course of the day. So, and there's been other studies in vegetable crops that have shown that there's some potential advantages to irrigating your crop this way. In some crops, there's been shown to have more yield and better fruit quality, which of course is important. Higher water use efficiency because you're applying the water as the plants need it. Reduced use of chemicals and fertilizers, and there was even one study that showed there was less emitter plugging with pulsing versus the standard method of irrigation. So on the left here is a graph from one of these studies where on the top was their control, where they just added the water all at once on a given day. On the bottom, they pulsed it. And basically what this shows is that when you pulse it, more of that water is staying near the soil surface. The other idea that may occur in some soils that when you pulse it, you get more lateral movement of water rather than deep percolation of water, although there's been studies to show that that's not really the case. But there was a study published in 2018 that showed pulse irrigation did increase production in strawberries. Now, this was done on a rocky soil. It's the reason why it works. But our raspberry growers started to question, is this method potentially useful for raspberries? So what we did is we went in and set up a study for raspberries. Now, there's about 20,000 acres of raspberries in the United States. About 50% of that production is in the Pacific Northwest. All our cultivars are floricane fruiting cultivars, and just about everything is machine harvested between July and August. Raspberry production, typically we plant at a pretty close spacing, 2.5 by 10 feet. I always use raised beds to help reduce root rot. Most of our soils, our good raspberry soils anyways, are silty or sandy type soils. And usually the plants are irrigated either by surface or subsurface drip irrigation, usually one line down the row, either suspended from the trellis wire or buried a few inches deep in the soil along the base of the plants. So what we did is we set up a trial where we had either standard irrigation or we had pulsed irrigation. So with the standard irrigation, this is what the grower was doing, which essentially was irrigating for up to 4 hours as needed. Oh, you're going to take care of it? Should I snooze that? Is that what I want to do? There we go. And then we got pulsed irrigation, where we applied the water for 30 minutes every 2 hours, applying the exact same amount of water that the grower was doing with their standard irrigation. So in this particular field, we had half-gallon per hour emitters that were spaced 20 inches apart. So here was the soil moisture readings that we did at under the drip emitter, 5 inches from the drip emitter, and 10 inches from the drip emitter. So what this basically just shows is that with standard irrigation versus the pulse, you can see how the pulsed irrigation is maintaining your soil moisture levels higher throughout the course of the day. So maintaining more water availability and potentially higher nutrient availability. And this figure, same thing, but just 4 inches deep under the drip emitter versus 12 inches. And again, with the pulsing, you're just maintaining a higher soil moisture level in the root zone with the pulsing than you do with the standard irrigation that the growers would use. So we didn't see any difference between treatments the first year of the study. Not surprising. We just started the irrigation treatments, wouldn't expect to see much effect on production. But the following year, what we started to see was that we got higher yields. So basically, in raspberries, when you're machine harvesting, you're going to usually harvest twice a week. And so this is showing each harvest over that course of that harvest season from early July to early August. And what we start to see is with pulsing, we were getting higher yields at each harvest in the later half of the harvest season. And this was primarily due to larger berry sizes. So we had larger berries that second year with the pulsing than we did with the standard method of irrigation. So overall, this translated into about 1,100 pounds of raspberries per acre, and a slight increase, which was due to that slight increase in berry weight. So based on the recent market prices at the time of this study, that was equal to about $1,000 per acre during that second year. We repeated the study again in the third year. Again, we found pretty much the same thing. We increased production about $1,000 per acre. In this case, in the second year, it was less due to increases in berry weight and more to increase the size of the canopy itself. So we measured the cover of the canopy, so how big that canopy got using our drone. With Pulse, we got a 55% canopy cover versus 49% with the standard. So basically the plants were growing more with the pulsed irrigation because they weren't becoming as water stressed. So they had better water status during dry periods. We also got more floricanes per plant, larger floricanes per plant. So when you got, of course, more, but also larger floricanes, you're going to produce more fruit. And then we also saw an increase in the diameter of the primocanes. And then once we actually trained the plants, we got it, and they now become floricanes. We again got an increase in the number of floricanes per plant. So just a quick summary of this particular study is that raspberry growers in Washington expressed an interest in using pulse drip irrigation, but they had questions on whether it was actually worth their while. Was it profitable? So what we discovered was that pulse drip irrigation increased production by about 7 to 11% during the second and third year of production, which was equal to about 1,000 pounds of fruit per acre. So based on recent market prices, that was about $1,000 per acre that we were able to increase production with raspberries. So with nearly 11,000 acres of raspberries in the Pacific Northwest, this could potentially lead to $10 million in production. We're also looking at pulse drip in blueberries, which also look promising, and I'll talk about that this afternoon in the blueberry session. So I will stop there, and do I have time for a question or two? Or? Okay, any question about pulsing or the blackberry lysimeters? Yes? Yes. So what the grower did in this case is that at around 2 a.m., they would just run their system for 4 hours every day. So what we did is we started at 6 a.m., but split up that 4 hours of irrigation in 30-minute blocks every 2 hours. Is essentially what we... Excuse me? Yeah, exactly, yes. Okay, all right, well, thank you.
All right, that was a very interesting presentation. Thank you, David. I'm going to fight with the computer here for a second. If anybody needs to get up and get their continuing education credits, feel free to do that. Our next speaker, perfect. Our next speaker is going to be Lisa DeVetter, and she also is based out of Washington State. She's going to discuss calcium and quality as it relates to the uptake, fertilizer efficacy, and impacts on raspberry fruit quality. Lisa, thank you for joining us today.
All right, thank you, Lisa, and thank you to the organizers. Came down with something on my flight over here, and as much as I love sharing information, I don't like sharing anything infectious. So hopefully, though, I can take my mask off and give a presentation and highlight some of the additional work we are doing in the Pacific Northwest. This time we're going to shift gears and talk about nutrient management. In particular, we're going to be focusing on calcium. Again, I'm at Washington State University. I'd like to highlight the individuals that worked on this project. We have Brian Maupin and Alexander Diaz de Silva. Brian's a technician. Alexander was a former student visiting from Brazil. And then we have our collaborators from USDA ARS. We just heard from Dr. David Bryla. We also worked with Scott Orr, technician in his program, and the Caneberry breeder at USDA in Corvallis, Oregon, Michael Hardigan. So just out of curiosity, by show of hands in this room, how many of you are caneberry growers and you are thinking or currently are applying calcium fertilizer for improvement in fruit quality? Okay, I'm seeing some gentle show of hands. So hopefully this presentation will address maybe some questions about that nutrient management practice based on work that we've done with raspberry, and I'll highlight some blackberry work in the Pacific Northwest. Let's first talk about what calcium is and why we're interested in it from a fruit quality perspective. So calcium is an essential plant macronutrient, meaning it's taken up in larger amounts compared to some of those micros that are traditionally applied through foliar feeding. The reason it's often connected to fruit quality is because of the role it has in the cell wall primarily, as well as the membrane. So calcium helps link pectins in the middle lamella, and that helps influence cell wall rigidity. And the thinking is the more calcium, the more rigid the cells, and the firmer the fruit. And that's important if we want fruit for good IQF characteristics, or at least that's the thinking, for the processing market as well as for fresh market, to ensure that that fruit is remaining intact throughout the post-harvest lifespan. There's also some beliefs that it might also help with plant health by reducing the potential for infection and infestation from diseases and pests. Calcium as a nutrient in the soil is actually rarely deficient if we look at our foliar tests, but that doesn't mean it can't be deficient in the fruit, which is a low transpiring organ. And I'll talk about how calcium moves into various organs, leaves and fruits, but what often we see in developing fruit tissue is that there can be these temporary deficiencies leading to issues with fruit quality. Some good, well-known examples would be bitter pit in apple and blossom end rot in tomato. A couple other things that can influence nutrient uptake with calcium is antagonism. So magnesium and potassium are a few examples that can compete with calcium for uptake. So let's highlight how calcium moves into our plant tissue. So calcium is available in the soil, either naturally present there or applied through fertilizers to the soil. It then is dissolved in the soil water solution and taken up by the plant roots. And then from there, the xylem, or the pipes, you can think of them, move that calcium as well as other nutrients dissolved in the xylem up to a sink tissue or transpiring tissue. And transpiring tissue, Dr. Bradley explained it really well, but a little bit more detail is that leaves as well as fruits have these pores called stomata. That's where gas exchange occurs. Water can evaporate, that provides a cooling effect, and that can leave calcium as well as other nutrients in that tissue. But again, there's periods of development where fruit tissue can have the stomata being closed that can limit transpirational movement of calcium from the xylem into developing fruit tissue, and then that xylem can constrict during periods of development as well. What growers often do in our region and with other crops is they try to provide calcium through foliar feeding or applying nutrients to the plant canopy. And I want to talk a little bit more about how this nutrient then can move into targeted tissue through foliar feeding and some of the barriers that can impact its movement into tissue. So first, the idea with foliar feeding is that nutrients will move through the cuticle, through cuticular pores, or through the stomata, which I mentioned earlier. But as fruit tissue develops, the cuticle layer, which is waxy, can thicken over time, so that can provide more of a barrier for movement of nutrients, particularly larger nutrients like calcium, into the tissue. And then the stomata can be covered as well. I often think of a nice study that Dr. Bryla's student did where they looked at the cuticle and layer wax development in blueberry tissue and how it thickened over time. And that can increase the resistance and the barrier of that nutrient moving into the tissue through foliar feeding. So I want to highlight the research justification now that we've gotten a little bit of background information about calcium. So for the Pacific Northwest industry as well as elsewhere, calcium fertilizers are applied with the idea that it's going to be enhancing fruit quality and shelf life. And for the processed industry, the main goal is to help improve firmness and cohesion of the druplet. So as it runs through an IQF line, we have reduced shattering in the fruit. And if we have more shattering, that reduces the value of that IQF fruit. And as I mentioned briefly earlier, for the fresh market, we want nice firm fruit so that when we harvest it and we put it in a clamshell, it's going to remain intact and of high quality for the consumer over a longer period of time. When it comes to nutrient applications, it's important to make sure that those nutrient applications align and overlap with key periods when that nutrient is being taken up. When it comes to raspberry and blackberry, we really don't know when those periods of nutrient uptake are occurring, which is one of the justifications for this research study. So that brings us to the objectives. So the objectives are twofold. First objective was simply to determine the timing and peak uptake periods of calcium in raspberry fruits and then leverage that information to inform fertilizer application strategies. And I'm going to be focusing primarily on raspberry, but some of this work has been done in blackberry as well, and I'll mention that as well. Then the second objective was to evaluate methods to increase calcium concentration in raspberry fruits and leaves, and then assess the impact that it has on yield and key variables of fruit quality. So objective number one, again, we're looking at when does that calcium accumulate in fruit tissue over a period of development. Our approach is outlined here. What we did is we collected developing buds, flowers, and fruits every 2 weeks in 2022, and we used 3 commercially important floricane fruiting red raspberry cultivars, Wakefield, Meeker, and Wakehaven. And this work was done in Linden, Washington. I'll show that on the map, but that's where about 99% of the processed red raspberry industry is concentrated in Washington state. A bit more about our sampling strategy and methodology. So we had a single field site that was managed by a single grower cooperator. Here is an aerial image of the field site and our 3 different cultivars. So that was important so that the management was consistent and it didn't vary based on the grower practices. And for each cultivar, we had 3 permanent transects or rows, and we sampled our developing tissue, again, every 2 weeks on both sides of the rows. The fertilizer rate was consistent across these different field sites, and we worked with our grower cooperator to ensure that no foliar nutrients were applied that might confound our results. So here's, again, our stages of development and what that coincides to. So again, we were sampling all the way through closed green buds to mature red fruit. And the number of samples varied just so that we could obtain 1 gram minimum of dried ground tissue per replicate. Then we dried that tissue, we sent it to Dr. Breila's lab, where they digested it in nitric acid and analyzed it using inductive coupled plasma optical emission spectrometer. And then from that, we could determine the dry weight of each stage in cultivar, its calcium content, and then how the calcium patterns of accumulation change over time. So let's take a look at that data for raspberry first. For what we have here is we have Wakefield on the left, Meeker, and Wakehaven. On the left y-axis, it might be a little hard if you're sitting in the back, that is calcium content in milligrams per berry, and that calcium content is represented by the black line in each figure. And then on the right of that y-axis is corresponding to dry weight, and that's represented by the gray line for each cultivar. And then we have our developmental stage as our x-axis. What we found is that peak periods of uptake were between S4 and S6, and that is the immature green and white fruit stages respectively. A couple of things we noticed, there were differences by cultivar. Meeker had a much higher rate of calcium accumulation within that window of time compared to Wakehaven and Wakefield. The other thing that we noticed is that once the fruit were harvested, so that white fruit stage and then to that ripe red fruit stage, is that there was a decline in calcium content, and we attribute that to the loss of the receptacle. So we pulled that ripe fruit and the receptacle remained on the plant. Prior sampling periods, the receptacle was included. But interestingly enough, Wakehaven did not have that dramatic loss in calcium content between those 2 sampling stages. This work was done in Blackberry too. This work was done in Oregon, led by Dr. Bryla's lab. These figures are set up in the same way. We, for this part of the study, used trailing Blackberry, Marion, Black Diamond, and Columbia Star. And the trend was very similar, so that peak uptake period between S4, but it extended all the way to S6 for Marion, but it went a little further for Columbia Star and Black Diamond, all the way to that ripe stage of fruit. What we noticed too, again, were some interesting cultivar differences. Uptake was greatest in Columbia Star, as you can see here, and that rate declines slightly at S5 in Black Diamond. Another interesting thing that we did is we took a subset of our Meeker raspberry fruits at the mature green, white fruit, and red fruit stages, and along the equator of the fruit, we exposed it to scanning electron microscopy to look at the microsurface characteristics and see what kind of factors might affect uptake of calcium, as well as if we're looking at foliar nutrient applications in the fruit. So what we saw is that overall on the fruit, there was lowest model density that could be utilized for, say, foliar feeding of calcium. We also noticed a high density of these filamentous epidermal hairs, and the rigidity of those hairs declined as the fruit ripened from white fruit to red fruit. Why this might be important? Well, looking at the literature on kiwi, which is a hairy, fuzzy fruit, what they observed is that as those hairs collapsed, it increased the boundary layer and reduced transpiration, and that could have an impact on loading of nutrients through that transpirational pathway. So we learned when calcium is being taken up. Now what we wanted to do in 2023 and continue on in 2024 is to look at methods to increase calcium concentrations through fertilizer applications that overlap with those key periods of uptake, and then understand what impact it has on yield and fruit quality. Just like the previous presentations, we're working with the processed crop that is machine harvested, and so the yield is machine harvestable yield. For this project, we worked with the same grower cooperator and the same fields, but we limited our study to Meeker and Wake Haven. And what we did is we set it up as a randomized complete block design where we had 3 different treatments that were replicated 4 times per cultivar, and each plot was 56 feet long in length. And so if you're interested in the experimental design, here's what it looks like. But again, we had 3 different treatments: a soil-applied calcium fertilizer, a foliar-applied calcium fertilizer, and an untreated control. And from that, we measured yield, fruit quality, and nutrient concentrations in the soils, in the leaves, and in the fruit tissue. We worked with our grower cooperator as well as other growers and crop consultants and asked what type of soil and foliar nutrients should we be evaluating that's relevant for you, and this is what they told us. So for a soil applied treatment, we use calcium sulfate, specifically Gypril, which is 22% calcium, and based on soil tests for that field site, we applied at a rate of 1 ton per acre in March of 2023. For our foliar treatment, our cooperators told us to apply NuCal. That's relevant for them. 8% of that calcium is derived from calcium hydroxide. And we applied at the high label rate, which is 8 quarts per acre diluted in 100 gallons. And we made a total of 8 applications every week with a non-ionic surfactant. And the application periods are here. That was important because, again, we wanted to overlap our application periods with the patterns of uptake for calcium that we observed in the previous year. And then we had an untreated control as well. So let's jump into the yield data. We have yield broken up by cultivar, so Meeker is going to be always on the left, Wake Haven is going to be on the right in these figures. You'll see we harvested Meeker 16 times and Wake Haven 17 times in last year. This was most of the harvest. We had a few instances where our grower cooperator forgot to tell us, so we missed 1 or 2 harvests depending on the cultivar. Because the number of plants varied by plot, I'm presenting the data as yield per plant. And it was really interesting to see that for Meeker, there was an increase in yield for our gypsum treatment and not for our foliar as well as our control. I don't really have a good explanation at this point because I was expecting no yield effects, at least for the first year, because those buds that contribute to yield developed the year prior. But nevertheless, we did saw an effect, and it'll be interesting to see if that trend holds true in the following year, in 2024. For Wake Haven, we saw no statistically significant effect of our treatments on yield. Now for fruit quality, we looked at several different variables of fruit quality. We looked at grams per berry, total soluble solids or sugar content is one way to look at it, pH, total titratable acidity, and we looked at the firmness. And what we saw was pretty easy to summarize, no differences in any of our fruit quality parameter. And we were most interested in this firmness because that's, again, one of the fundamental ideas of applying calcium is augmenting firmness in that fruit tissue. But we saw no effect on firmness in both Wake Haven and in Meeker. Now turning our attention to nutrient concentrations, we sampled primocane leaves for nutrient analyses. And we sample primocane leaves because that's standard for our industry and it allows us to compare to sufficiency standards. What we observed was no treatment effects on leaf calcium concentrations for both of our cultivars. And when we compared to our sufficiency ranges, all of our treatments were within our sufficiency levels of 0.6 to 2% calcium. For soil calcium, what we observed, similar trend here, there was no statistically significant effect on our soil calcium levels. I do want to point out, though, it was an interesting trend, although not statistically significant, that we did see 14 to 25% higher calcium with our gypsum treatment in Wake Haven. And I think this is perhaps the most interesting piece of data and has really been changing my thinking about nutrient applications in raspberry, particularly calcium. So what we did for our raspberry fruits is we looked at calcium in the fruit tissue and we looked at it separately from the receptacle. And what we observed is that the receptacle contained far greater calcium than the fruit tissue. And you can see that here for Wake Haven, we have fruit concentrations of calcium ranging from 0.1 to 0.1 to 1 to 0.12, and then the receptacle range from 1.15 to 1.37. The other interesting observation was that for Wake Haven only, not for Meeker, is that we saw this significant effect of our treatments on calcium concentrations in the receptacle. So foliar feeding led to higher concentrations of calcium in the receptacle, followed by our soil applied gypsum, and then our untreated control having the lowest amount. So our conclusions and next steps and how we're thinking about this. So number one, we learned that patterns of calcium uptake and accumulation vary by cultivar, and that could influence nutrient management strategies for this nutrient. We saw few treatment effects with our fertilizer trial, but the key thing again that jumps out to me is that calcium accumulates in the receptacle. And so it might actually be very difficult to get calcium into the fruit tissue to change firmness and cohesiveness in the fruit because of this preferential accumulation in the receptacle tissue. Another interesting finding in a paper I was reading, the researchers applied a precursor to calcium synthesis. They noticed an increase in calcium in the receptacle as well. But what that actually caused was something detrimental. It increased the force that they needed to apply to remove the fruit from the receptacle. So there might actually be some negative aspects if we increase receptacle calcium too much in terms of release of the fruit from the receptacle and picking efficiency. This is, again, the first year of our fertilizer trials. We hope to repeat this in 2024, possibly look at some higher rates, and continue on with measuring some of these metrics that I presented here. With that, and before I open up for questions, I'd like to acknowledge that this project has been funded from the Washington Red Raspberry Commission, the Northwest Center for Small Fruits Research. We also work closely with Raider Farms. They're our grower cooperator. And again, when you're picking every other day for harvest, everyone has the opportunity to help out in the lab. So I also want to acknowledge the Small Fruit Horticulture Lab for all their contributions to this project, as well as Alexander, the student. So with that, I'd like to thank you, and it looks like I have plenty of time for questions. If anyone has any questions, I'd be happy to take them.
All right, everyone. Thanks for the introduction, Lisa. So yeah, today what I really want to do is kind of talk about, and Lisa's previous talk, I kind of set this up for me. I want to talk about the use of doing leaf tissue nutrient analysis on blackberry and kind of how that can be a tool for you to check in on the nutrient status of your crop. And figure out, am I doing a good job with my nitrogen, phosphorus, potassium applications? Do I need to change anything? And then also give you all an update on some of the work that we've been doing as a kind of a regional team to just verify the recommendations that we have established as far as how much nitrogen do we think needs to be in a blackberry plant in post-harvest. And then also, are there some ways that maybe we can develop new recommendations for when you can do some leaf tissue analysis? So I'm not sure how many of you might be strawberry growers, but with strawberries we can leaf tissue nutrient sample throughout the season, starting at bloom and then heading into fruiting. And it really gives us this opportunity to amend our fertility program in the same season. One of the limitations of using leaf tissue nutrient sampling in blackberries is that our current recommendations dictate that we do that sampling in post-harvest. And so when you check in with the plants at that point, you're really just trying to figure out how well you did earlier in the season and then make some changes going into the next season. And so we're always a little bit behind in a way, and so we're trying to develop some potential ways to test earlier in the season. So that's what I want to talk about today. But just to kick things off, I think it's always important to kind of think about, where are nutrients moving out there in the field? And particularly because blackberries are a perennial crop, things can get a little bit more complicated. In an annual crop, you put out everything, the plants are going to take it up and immediately make that fruit. In blackberries, particularly with the biennial cane nature, what we put out this year is actually in a lot of ways determining fruit production for the next year. So if you get behind, you're really behind because the things that you did this year are determining things 12 months from now. But if we look out there, we know that there's going to be nutrients stored in the crown of the plant, that there's nutrients held in those leaves and canes. There's, of course, nutrients held in the soil and also nutrients in the fruit. And I always like to think about, all right, so how am I kind of looking at my bank of nutrients? So, we definitely know that there's some money stored in the soil in those nutrients. And those leaves or the nutrients that are stored in your crown and your leaves and canes are also going to be moving around and going into that fruit. But of course, we remove that fruit from the field each year, so that's a removal from your bank of nutrients that you have out there. And Bernadine Strict, who has been mentioned several times today, did a lot of kind of the base work for our understanding of how much nutrients are actually being removed from the field each year in either fruit or in the canes. And so this is kind of the estimate that we have of that there's about 12 to 18 pounds, and this is per acre, that is removed in the fruit each year for nitrogen. And then there's about 33 to 55 pounds of nitrogen per acre in the canes. And then you can kind of go down less phosphorus, a pretty good amount of potassium. So about 14 pounds in the fruit and 35 pounds in the canes. So this is something that we need to be thinking about. Every year, those plants are accessing the nutrients that are held in the soil or that we are applying via fertilizer, moving through the plant, and then some of those nutrients are being actually removed from the field when we harvest and move that fruit out. So we got to make sure that we are replenishing that nutrient bank in the soil by applying fertilizer. But it's also important to remember that there is some nutrient movement back downward as well. So plants also move nutrients back down into the crown in the fall. And one question we get very often is particularly looking at these numbers on the amount of nutrients that can be removed in the canes. Growers are very interested in trying to save those nutrients. So if I remove those canes and I mulch them and I put them back in the row middles, is that a way to kind of cycle nutrients back into the system? Talking to the plant pathologist, that's something that makes them very nervous, particularly in the southeast where we have a lot of cane and leaf diseases, that there's a potential for us to be increasing that bank of pathogens. And so our current recommendation is still to remove those canes from the field when you're pruning things out and not to mulch them back into the row middles, even though you are losing some nutrients doing that. And then, of course, one of the ways that we have to balance all of this is by adding more nutrients back into the system each year and applied fertilizer so that hopefully we're balancing what is being removed and feeding that crop sufficiently. But as I alluded to before, something that's a little bit complicated particularly with blackberries, is that we have canes that are new and growing each year, and then we have canes that are now in their second year and about to complete their life cycle, and they're going to die. And so it gets a little complicated with fluorocanes versus primocanes is where do those different canes pull their nutrients from? And so some of the work that has been done previously has been able to demonstrate that primocanes are really growing this year based off of the fertility that you're applying in the season. So when you go out and apply your bag of triple 13 or whatever it's going to be, a lot of those nutrients are going directly into that new growing point, the primocane. And that's kind of the sink for where those nutrients that you apply this year are going. Whereas the fluorocane is primarily growing off of nutrients that it took up from the previous year. And so this goes back to what I said before about if we can get behind really quickly, because if you're not doing a good job of fertilizing this year, you're actually impacting next year's crop or next year's fluorocanes. So growth is dependent on nutrients stored from the previous year. We have been able to see that current season nitrogen applications can impact fruit size this year, and that there's excess nitrogen can be allocated to the fruit. And this is something goes back to, we talked about red cell reversion yesterday, and that excess nitrogen applications can have a negative impact on fruit quality, and this is kind of tied in with all of that. And I do want to mention that, primarily in the Southeast, we focus on fluorocane fruiting type blackberries, and so that's what I'm going to focus on today. But for primocane fruiting types, they're going to act a little bit differently and may actually have higher nutrient and fertility requirements. And we're doing a little bit of work in Arkansas kind of trying to identify, does nitrogen move differently in a primocane fruiting type than a fluorocane fruiting type? And we'll hopefully have some results from that research next year. The other thing I always like to point out to people is thinking about the timing of your fertility application. And Lisa DeVetter did a really nice job of trying to figure out, with calcium specifically, when is the plant trying to take those nutrients up. What we know about blackberries is that, going back to what I just said, that most of the nutrients that you apply this year are going to go straight into that primocane. That means that we really want to target the start of our nutrient applications to when the primocanes start to grow. So that should really kick off when your nitrogen demand for the season starts and when you start making your first applications. But also need to be aware that there are demands for other nutrients depending on the stage of the crop development. So there is a higher demand for boron at flowering, and that's true for a lot of fruiting crops. And then what we may want to do is just be a little aware of not making excessive applications, particularly of nitrogen during harvest, because of some of the issues I just talked about, that there can be some negative impacts on fruit quality. But of course, once harvest is over, very often we're trying to push a little bit more primocane growth at the end of the season, and that gives us a good opportunity to make some final nitrogen applications. One thing that we do want to be a little careful about, and this is something that particularly with our fluctuating winter climates that I think many of you are about to experience next week or later this weekend, I do always caution growers about making your nitrogen applications in the fall too late. And so we really recommend making your last nitrogen application in late July or early August, and then stopping after that, just to make sure that you're not pushing a lot of green tender growth when we're really trying to get the plants to start to think about going dormant in the early fall and into winter. So here are kind of our general recommendations that we have for the Southeast right now. So if you go and look at the Southeastern Caneberry crop guide, this is what you're going to see. Right now, we recommend that you apply 50 to 80 pounds of nitrogen. And I would say more typically what I see is probably 60 to 90 pound range. And we are currently doing some work also in Arkansas to kind of identify that. So we have a trial where we are applying 0 pounds of nitrogen to blackberries all the way up to 150 pounds of nitrogen. And we're in the second year of that trial, and we'll be continuing it for one more year, and hopefully we'll have some recommendations on if that range still works for us. Nitrogen, of course, is important because it contributes to cane growth and fruit size, but of course, if we apply too much, you can be creating a lot more work for yourself because then you won't have to still go in there and remove all those canes and the excess cane growth that you grew. Excess nitrogen can also result in longer internode spacing, which has been attributed to reduced yield, and of course there can be some fruit quality disorders associated with applying too much nitrogen. So that 50 to 80 pound or 60 to 90 pound rate is for an established crop. In the year of establishment or the year of planting, 25 to 50 pounds of actual nitrogen per acre would be recommended. Phosphorus, our recommended rate is 60 to 80 pounds per acre, and really that should be on an as-needed basis. So very often when you first prep your soil before you plant, you're going to apply some phosphorus and get it up into the recommended range, and then from there on you'll probably do some soil sampling and then some leaf tissue sampling, as I'll talk about, and just kind of monitor if additional phosphorus applications are going to be needed. Just keep in mind that phosphorus very often gets applied broadcast, and then it's going to be in the soil surface, and it's going to be slower to move down into the soil. And so if you are identifying that phosphorus might be deficient in your crop and then you apply phosphorus, expect that it may take a little while before it actually moves in. And then potassium is another one, and if you think back to that slide I showed you about how much potassium is being removed in the fruit each year, there's a lot of potassium in fruit, and I think that very often we focus on nitrogen and maybe don't put as much emphasis on potassium in the southeast, but it's something that's going to be very important for fruit production and fruit quality. Our current recommended rates are to apply about 40 to 60 pounds per acre on an annual basis. Potassium, again, important for fruit quality, cane density. Again, be aware that broadcast applications can be slow to move into the soil. Fertigation applications from our research can be really effective for increasing plant tissue potassium if you're in a deficient situation. So potassium nitrate is a nice choice. And then I always mention boron, it's as needed kind of thing. Of course, you want to be careful about the timing and careful about the rate. You can very quickly over-apply boron and get into a toxicity situation. But it is important for the plant to have sufficient boron during flowering and can impact fruit's quality. Most often in strawberries is where we see it, where if you get a lot of deformed fruit, it can be associated with the boron deficiency. So that's kind of the overview of what we recommend as far as nutrients, timing of applications. The thing that I want to talk about today is using leaf tissue nutrient sampling just to check in and see, all right, I'm doing all these things, are my plants getting the nutrients that they need? And this is just kind of your way to monitor the nutrients in your bank. And plant tissue nutrient sampling should really be kind of paired with soil sampling. So soil testing is going to tell you what nutrients are held in the bank in the soil. And most importantly, it's going to tell you your soil pH. And soil pH can have a really big impact on the availability of nutrients and how easily plants can take up those nutrients. And so doing regular soil testing, particularly if your soil tends to run pretty acid and you might need to be doing some liming, can kind of give you an idea of what's going to be available to the plants. Plant tissue nutrient sampling, however, is telling you what those plants are actually accessing out of the soil or out of the fertility that you're applying. So it's kind of a way to back check and see is my fertility program really working. The thing about plant tissue nutrient testing is that we have to be very careful about when we do it and then choosing the right type of leaves on the plant. And the reason for this is that we develop these recommended nutrient ranges for these crops by going out and doing a lot of sampling and doing it off of a very specific part of the plant and at very specific timings. And so those ranges are based off of doing that sampling in the exact same way that we did the original sampling. So if you sample at a different time or you sample a different plant part, it's going to be very hard to compare your results to the established ranges. And so this is where we are trying to figure out, are there some ways that maybe we can sample at more times in the season to make it a little bit easier for people. But here is the current recommendation. So for floricane fruiting blackberries, the recommendation is to collect 50 to 100 of the most recently mature leaves. And a most recently mature leaf is indicated here in this picture with the red arrow. So it's going to be a leaf that is 4 to 5 leaves back from the growing point on the primocane. So it's a fully expanded, it's not one of those leaves that's still kind of opening up, and you're going to want to collect 50 to 100 of those across your field. And the timing for this is for it to be sampled, again, off the primocanes in late July or early August after harvest. And so you can check in with the plants at that time. For primocane fruiters, as I mentioned before, because they act a little bit differently, you're also going to be collecting most recently mature leaves from primocanes, but doing so at the red to green fruit stage of the primocane crop. So here is our current recommended ranges for how much nitrogen, phosphorus, potassium, etc. we think should be in those primocane leaves in the southeast if you sample in post-harvest. So somewhere between 2 to 3% nitrogen, 1.5 to 2.5% potassium going on. And this chart is available in the Southeastern Regional Caneberry Production Guide, but you can always check and see if your local state might have different recommendations. And basically what we want to do in our research is just verify, are these ranges correct? In part because some of these ranges were originally developed for the West Coast and for Western type blackberries. And then some of the ranges that are available are based off of best estimates of how much nutrients that we think should be in the crop. So with that goal in mind, what we did was we got a team together of specialists all across the region, and we have been doing pretty intensive leaf tissue nutrient sampling of blackberry plantings just to try and check in and see, all right, how many or what percentage of nitrogen, phosphorus, potassium are present in the crop at different times. So this is our team. Elena Konova is at Auburn, Gina Fernandez and Karen Bledow are at North Carolina, Dave Lockwood and Natalie are in Tennessee. I'm leading the team in Arkansas. Zilfina, who is our next speaker, is at Georgia. Jayesh Samtani in Virginia, and Eric Staffney in Mississippi. And so this is what we did. Over the last 2 years, we've gone out and pulled leaf tissue nutrient samples off most recently mature leaves at 5 different sampling periods on floricane. So one is at bloom, one is at primocane emergence, when primocanes are about 6 inches in height. One is at small green fruit. We pull samples at harvest, and then also at post-harvest. And so post-harvest is our standard recommendation. And then we pulled similar samples also off of the primocanes. So for the most part, primocanes are not present during bloom at most locations, but not at all locations. And so some of our locations have also pulled primocane samples earlier at bloom. And so we've had a pretty intensive sampling, and this has gone on, as I said, for the last 2 years at all of these different locations, and in some cases on multiple different cultivars. And so we are still analyzing some of the results, and some of the samples are still being processed by the lab, but I did want to go ahead and give you kind of a preview of some of the results that we're starting to see. We're hoping that our final results will be ready later this spring. So this is just kind of an overview of how much leaf tissue nitrogen did we see at bloom, at primocane 6 inches, small green fruit, harvest, post-harvest during the 2 years that we've done this. So we see a little bit of variability between the 2 years, between 2022 and 2023. But the big thing that I want you to notice about this is notice how much nitrogen is present in the plant early in the season during bloom versus it slowly kind of tails off and is lower during post-harvest. And so here are some actual averages. So like if you want to go out and do some leaf sampling later this year, you can compare them to the averages that we got across our 2 years. So the blue bar is floricane, so how much nitrogen was present in the floricane at these different stages, and the red bar is how much nitrogen or potassium on the bottom was present in the primocane. One thing that I want you to notice is that first off, those red bars are all pretty much consistently larger than the blue bars for both nitrogen and for potassium. So there's higher amounts of nutrients of these two nutrients in the primocane than there are in the floricane. And that for nitrogen, again, you see that there's kind of this trend of higher nitrogen early in the season, and then it slowly starts to tail off later in the season. Whereas for leaf potassium, it stays a little bit more consistent throughout the season. Now here's where we can start to get ourselves into a little bit of trouble, is our recommended leaf tissue range for post-harvest on a primocane is 2 to 3%. And you can see that on average, our samples were falling within that range. However, if you went out and pulled samples during bloom, on average, we were getting around 3.81% of nitrogen in the primocanes early in the season. And if you were trying to compare that to the recommended range that's established for post-harvest, you're going to think you're doing really good. But maybe you're not. Maybe it's just that it's an earlier time period and you're sampling at the wrong time. The thing that I think has been very interesting is that the range for potassium, we almost never hit the correct range. And so the range that we have had published for a while may actually be too high. And this is something that we're going to continue to look at over the next few months. But kind of just as a recap, this was our averages, and there on the top in the bold is the recommended range that we have for these different nutrients that is published in the 2016 Caneberry Guide. We actually also did a small sampling program in 2021, so I included those results as well. And we pretty consistently, on average, are hitting our target range of between 2 and 3% nitrogen in that post-harvest sampling period. Potassium is in red because we never have been able to actually hit that, so we might need to amend that recommended range. And then phosphorus, also, we have consistently been a little bit low on phosphorus. So our range, or our average is closer to 0.2%, whereas our range is recommended 0.25 to 0.4. So we're hoping to kind of review this and make some updated recommendations. And I do just want to re-emphasize that our 2023 samples, you'll notice that we only have 46 samples included in the data set right now, and that's because we still have about 30 or 40 samples that are at the lab and being analyzed. So this will be updated with that complete data set later. So my general recommendations is if you are doing leaf tissue sampling at the recommended time in post-harvest and you get your nitrogen results back and they fall within the recommended range, that means that very likely the way that you are fertilizing is working well and that you should continue kind of that current fertility practice for next year. If, however, if your sample comes back low in nitrogen, there's two kind of ways to think about this. If you got really good primocane growth and you feel like your plant health is really good, I would say continue doing the fertility practices that you're doing, or maybe do a slightly reduced nitrogen rate. If you have really poor primocane growth, however, you're probably going to want to increase your nitrogen rate. And part of the reason why I say that is that sometimes nitrogen will come back low if you're applying a really high rate and is kind of getting a dilution effect because the plants are growing very vigorously. So if the plants look good and green and you're getting a lot of growth, you probably don't need to apply more nitrogen next year. Phosphorus, again, if phosphorus comes back low, you probably do need to make an application. There's no research really that indicates that yield is increased with phosphorus applications, but if your soil test and your leaf test are in agreement that your phosphorus is low, you can make an application in late winter. And then potassium, keep in mind again that if you make really high rates of nitrogen, you can have an increase in potassium deficiencies. And leaf tissue potassium content, again, will be slow to respond to broadcast potassium applications, but if you're seeing that consistently you're low on your leaf tissue samples, you may want to increase your rate there. I will mention that we've done a lot of work with the rotating cross-arm trellis. And on that trellis in particular, because of the really high fruit load per linear row foot, we've actually seen that potassium deficiencies seem to pop up earlier on that system. So you may also want to sample different trellising systems differently, just to keep an eye on those kinds of things. And then boron, of course, you can make broadcast or foliar applications of about 1 pound per acre if you see that boron is low on your leaf tissue samples. But again, you'll be doing that sampling in August, and I would recommend waiting to make that boron application until the next spring so that it more closely coincides with bloom. And so I want to thank the Southern Region Small Fruit Consortium. They're the original group that funded this research, and also really want to thank the entire team of specialists and county agents that have been really pivotal in helping make this research happen. And then also the Arkansas Fertilizer Checkoff Funds, which have supported our work as well. And then there is my email and our blog and our YouTube channel, and I'm happy to take any questions if I have time.
People can jump in at 11 if they come in. So this is the last presentation before we take a break for lunch. So don't forget to scan before this presentation if you need pesticide credits. So our next presenter is Dr. Zelfina Rubio Ames. And she's from the University of Georgia. She's a small fruit extension specialist, and I think her presentation ties really well into Dr. McWhort's. So she's going to talk about SAP, nutrient analysis for blackberries. So we're excited to have you, and thank you for being here.
Hello, everyone. Once again, my name is Silfina Rubio, and I'm the assistant professor and small fruit extension specialist at the University of Georgia, based in Tifton. I've been with the University of Georgia for about 2 years, and today I'm going to show you some sap nutrient analysis work that we've been doing for this past 2 years. And this was basically something that I was asked to look into because the growers were very interested on seeing how sap analysis can being used as a tool, or maybe pair it with sample leaf tissue sample and soil sample. And a lot of the growers were sending this material, plant material for sap analysis to external laboratories outside the United States. So I was they were asked about it. They didn't know exactly if what they were doing was right. They didn't know how to interpret the analysis after they got the results. So I started looking at it, and I have some results for you to show it. I don't have all the data analyzed yet, but I'll give you some preliminary information. So first, to start talking about a little bit the blackberry industry in Georgia. That acres is still small compared to other blackberry producing states, but it's been increasing. We have about 820 acres of blackberries, mainly located in the south part of Georgia. And our season is very short, goes from mid-May to mid-July. As several areas in the southeast, we relied on the Arkansas breeding program. So we plant a lot of varieties that were released by the Arkansas breeding program. The most planted variety is Washita, but the newly released varieties are also being planted, like Caro, Sage, and Ponca. And Bon is also a variety that is being planted by blackberry growers in Georgia. So now moving on to, what is the difference between leaf tissue samples and, and sap analysis. So the leaf tissue sample actually measures, the accumulation of nutrients in the leaves, and it tells you, what the plant accumulated. But some of the nutrients, stay in the leaves and they don't move as easily as other nutrients, like nitrogen is very mobile, calcium is not very mobile from the leaves to other parts of the plant. And SAP actually measures, it's trying to understand more that nutrient content that is readily available to the plant. It's kind of more like an in situ type of analysis. Some background information on SAP analysis. It's commonly used in vegetable production and greenhouse production. It's not very well used and very well understood for perennial crops. So the literature, that I review, it's mainly that I was on apples, and I heard some other colleagues from Wisconsin that the apple growers use it over there, but they stopped using. And the reason for that, I think it's because, there is a lot of kind of unknown area of when it's best to take this sample. A lot of the growers, for example, in Georgia are, asked to take it, before 9 a.m. Some others take it in the afternoon. Then again, they don't know if it's best to take. Some growers take the leaf samples, or others take the petiole sap. So there is not actually kind of a specific protocol for our methodology to collect the sample. And depends on the crop. Your measure sometimes it could be petioles, sometimes it could be leaves. So there is still a lot of things that we need to learn about. What is the best methodology to do sap analysis. But also, why is this important? So it's important because it gives us a rapid diagnosis from either deficiencies or excess of nutrients. And in the case that we have excess of nutrients, we are putting too much to the plant, which we don't want that. And, Amanda did a really nice job on looking, why do you want to be over-fertilizing? You don't want that nitrogen to be high because it will affect fruit quality. And we're also, if you're applying extra amounts of fertilizers, well, you're increasing your production costs and you're not utilizing, everything you're putting in. The plant is not getting it. It's just, a fertilizer just going down the drain. And it also, like if we will be able to, identify if there is any excess of nutrients or deficiency, we will be able to increase our fertilizer use efficiency. And we reduce the leaching, and therefore we can, have a more sustainable blackberry production system. So for this research, some objectives that we have, and this was a collaboration with the Agricultural and Environmental lab in Athens, the lab does all the soil and tissue samples for the University of Georgia, because since there was interest for, the growers were interested in adding this analysis, they wanted to see if they will be able to provide this service to the growers. So one main thing that we looked first, it was the methodology. So when do we actually need to take these samples, and if there is any difference if we take it at 9 a.m. or we take it at noon or at 3 p.m. We're going to sample the leaf, what is going to be best, the leaf, the tissue, or the petiole, and then maybe also trying to see if some things that we see in the sap will maybe be correlated with either the soil or the leaf tissue sample. So today I'm only going to show you results on the timing of the sampling. Also, the differences between the petiole and the leaf, and some correlations between the leaf tissue samples and sap. So we had this blackberry field that was located in Omega, and we sampled Washita and bone, and we sampled leaf and petiole 3 times during the day. This was our blackberry production field that was 4 years into production. It was variegated. The pH was about 6.2, and it was a very sandy soil, as you can see there. So the methodology is that, we took the petioles and the leaves, we sent it to the lab and made dilutions to measure the sap, and this is all was done at the University of Georgia lab in Athens. So now moving on to results. So first we're going to look at time, and you can see that you have the 2 varieties and the sampling time from 9 a.m., noon, and 3 p.m. And then the sap nutrient content, the nitrogen sap nutrient content. As you can see there are no significant differences on the nitrogen content for sap at any time of the, any sampling time. There you're going to look at phosphorus nutrient content in the sap. We did not find any significant differences on sampling time for Washita, but we did see significant differences at 9 a.m. for bone, in which we have a higher content of phosphorus in the sap for that variety when we sample at 9 a.m. We also saw some significant difference again in bone for potassium, in which we also found an increase in potassium content in the sap at 9 a.m. And we did not see any difference on Washita. So now I wanted to see if, we were trying to look at the data from several, perspectives and see if there is any differences or any interactions between the leaf sap and the petiole sap and the timing of the sampling. And this is only on Washita, and we did not find any significant differences between the nitrogen content from the leaf and the petiole at any different, any of those 3 sampling times. For phosphorus dot on Washita, we found that we have a higher content of phosphorus in the petiole sap for Washita, and the same, and then kind of like a low phosphorus content in when we sample at 3 p.m. and on the leaf sap. And also we kind of saw the similar trend for also this is Washita there, and on the petiole sap, in which we had higher potassium content on the petiole sap, and there is still no difference on time. We also were looking at some trends through the season, because we sampled several times during the season. And as you can see there is a different, when we put all the data together, we saw some differences on the leaf sap and the petiole sap on the nutrient content from nitrogen, phosphorus, and potassium. but all of those nutrients kind of like reduce in their content when we sample in May. So there is, as you saw from the leaf tissue sample, also we can see this changing in the nutrient content in the sap as the season moves along, which kind of like, give us the similar idea of the leaf tissue sample, but also it's going to be important to decide when in the season we're going to have a more accurate, sampling time and accurate results from our sampling. So we still need to look more into this, into like learning when it's going to be the specific sampling time for sap analysis. We also, as I mentioned before, we wanted to see some correlations, and this is like a lot to do, but I'll just give you a lot to understand, but I'll just give you the take-home message. What we wanted to see is that either the leaf nutrient, total nitrogen content, or phosphorus or potassium content will relate somehow with the sap analysis. Once again, the leaf sap, it's not something that is going to replace leaf tissue sample, but it will be an additional test so growers can customize their fertilization practices more to what they're seeing on their field. So we did not find any relationships between the total nutrient content of nitrogen in the sap and in the leaf. And we also tried to see what if we move that target to 2 weeks after. So if we compare the 2 weeks sampling after we take the sap analysis. So if I take the sap analysis today and I take my tissue sample 2 weeks after, if there any relationship, if we see any nutrient content differences. And we did not find anything for either nitrogen or potassium. There is phosphorus. There is a little bit of like a higher R-square there, but it's still really hard to see a relationship. And also for potassium, we did not find. So we're still trying to see how we interpret this data. And I think a key aspect of this, it's because we don't have sufficient levels for sap. So a lot of these companies that are providing this service outside the United States for growers, they do have their sufficient levels. But we, as the University of Georgia, or in the United States, or in either in the southeast growing regions, we don't have these values. So it's very hard to correlate and see, okay, I am seeing a deficiency in my sap. Maybe I have like low nitrogen or low phosphorus, because we don't have those sufficient levels that we need to base ourselves on. That is usually ones that we use for leaf tissue samples, in which we do have those sufficient levels. So once again, there was no significant differences on the sampling time during the day from 9, noon, or 3 p.m. We saw a higher petiole concentration for phosphorus and potassium, and we could not draw any conclusions or relationships between the leaf tissue samples and the sap tissue samples. So with that, I would like to thank the Georgia Farm Bureau for funding this project and my lab members, and I will be open for questions.